Good morning, Pulak. How are you?
I'm doing good.
Good. So recently I had the opportunity to sit down with Ennetix CEO, Biswanath Mukherjee, and talk about holistic observability and how it relates to IT and problem solving and outage resolution. So today I wanted to talk to you more about kind of going into that technical deep dive and look at the specifics of how you collect data and how that's used to ultimately determine where the problems are.
Yeah, good to see you, Chris. So, in simple terms, holistic observability means exploiting that available data to get a complete picture of what is going on in that infrastructure. To achieve this, there are three important steps. First, we need to organize the data in a meaningful and efficient way. We need to extract value out of the data. We can call it signal extraction. The third step is to create meaningful correlations of the data.
Yeah, so that's a very natural flow of how you would look at the analysis. But let's kind of take a look at that first step. So we're talking about organizing that data and looking at how you collect that and then ultimately process it and then put it in a meaningful form.
Yeah. So essentially, there are three key elements of data organization: temporality, spatiality, and provenance of data. So let's start with the first one. Temporality is simple. It's basically temporal timestamp of the data, when the data occurred. The spatiality is about the origin of the data, where the data is coming from. Is it coming from your server infrastructure? Is it coming from the network? Is it coming from the applications? Or is it coming from the user devices? The third one is called provenance. It's a little bit more interesting. It's the origin history of the data from the source. So when data is coming to you, you have to understand what are the source of data, how it is coming to you. Is it coming directly from the devices, or is it coming from another software which already analyzes the data and creates some analytics around the data? So it's in short, all these three things create the well-organized data structure that can be useful for holistic observability.
Yeah, that's really interesting. So do you do organization of that data beforehand, or is it all in post-analytic and analysis of the data?
Yeah. So once you organize the data, you still have huge amount of data. So you have to figure out how to extract meaningful information about the data. So we can call it signal extraction. Let's take a simple example. Let's say a syslog. A syslog coming to you, it can be saying CPU utilization is high. Now, you have to first find out what it is talking about. We can call it topic of the data. So you have to figure out the topic is about CPU utilization. The second step is to figure out when you say something is high, how high it is. So what is the value out of it? And also whether we should worry about that data or not. So that is the sense of signal extraction from the data.
Interesting. So when you have clients that are accessing mission critical applications and they're having problems, what sorts of important metrics do you look for, and how do you highlight when there's a problem?
Yeah, the signals can come in different formats. The obvious ones are very simple, they are coming from the devices, the device telemetrics, metric data. It can be CPU utilization, it can be memory, it can be input and output, and other types of metrics. And also passive traffic metrics can give you information about the client-server interactions. Interestingly, signal can come in other formats too, rather unsimilar formats. Let's take an example of tweets during the largest scale internet outages. The sentiment analysis of the tweets can give you important information about how severe the outage is and what it is impacting. So that's another type of signal.
Right. So when we talk about dimensionality, can you expand on that? Can you maybe give more in-depth description about what is dimensionality?
Yes. So dimensionality means the attributes of the data. So when data comes to you, you have to determine where you can use the data, and that's where the attribute comes in handy. Let's take another example. Let's say consider a device which is under a distributed denial of service attack, or DDoS attack as we call it. And it is most probably data can be coming in multiple different sources. It can come from as a format like CPU utilization of the device is high, the device is having high traffic load, device can be showing some other high resource utilization. So all these things can come to you in multiple formats and multiple ways. Now you have to use the data to find out either a security incident, in this case a DDoS attack, or it can be a performance incident that delays in response of data.
So I guess maybe the third part of holistic observability is the correlation, right? So we talk about high CPU, we talk about high memory, but what do you do from a correlation perspective?
Yeah. So regarding correlation of the data, I think we all know that correlation is not the causation.
Mm-hmm.
So the simple correlations like temporal correlation, basically two events happening at the same time, but they cannot give you exact reason why those two events are happening at the same time.
Right.
There can be another type of correlation, we can call it spatial correlation.
Mm-hmm.
So things happening at the same place. Let's say one server having high load and high CPU utilization, they are correlated spatially because they're happening on the same server. But that does not give you information about why that is happening. The important correlation, we call it causal correlation. So causal correlation means using temporal and spatial correlation to find out the exact why something is happening, the causality of the correlation.
Great. So causal correlation is really interesting. I mean, maybe expand on that a little bit and more. What does that really mean?
So causal correlation is, as I meant before, as talked about before, like using temporal and spatial correlationships to create the relationship between the entities. So let's take an example. Like let's say when you are accessing an application, most probably the user of that application is trying to access a DNS server for name resolution. Now, if the DNS server is delayed in response, the user might be thinking, oh, my application access is slow. Mm-hmm. So there is a relationship between the DNS server access and the application server access. So that relationship that can give you, if you can discover that and use it to your advantage to find out the exact root cause of problems, that can give you effective way of determining the problem faster.
Right. So that's really interesting. So when I talked to Biz earlier on, we talked about performance and security. So, we talked a lot about the performance side of it, but maybe you can touch a little bit on the security part of this as well.
Yeah, so at Ennetix, we do not consider performance and security events separately. We consider them, they are events that are happening on the same infrastructure, so we should consider them in its own. So you have to ingest data, relevant data that is coming from the infrastructure, and then use them to your advantage to determine the root cause of the problem. Let me give you a simple example. This is a thing that happened in one of our clients' infrastructure. So in this case, there was this firewall which was sitting on the path to the authorization servers. And when users are trying to access the application, they're going through the firewall to get an authorization from the authorization servers. Now what happened? The firewall was under DDoS attack, and the firewall session table was full, and the user authorization request are not being forwarded to the authorization server. In this case, both the application servers and the authorization server, they are perfectly fine. But to the user, they are considering, oh, I cannot access the application, because they do not know exactly the root cause of the problem, because the authorization server could not forward them the request. So what ultimately you see here, one security incident, in this case a DDoS attack, is impacting the performance of the user on the performance side. So it is very important to understand security and performance events, they are very much interdependent with each other. So you should consider them in its own.
So that's kind of what we talked about as far as that causal relationship, right? So that's a great example. When we talk about holistic observability in more detail, I also understand we have another partner named Todd that works with Ennetix. He's going to be talking a bit more about the security part of it. So hopefully we can, basically look at the entire holistic observability as one IT performance package and its infrastructure.
Yeah, thank you, Chris.
Thank you very much.
Yeah, sure.